Hi, this is Joe. Now I'm going to give a technical description of the smart indoor system and explain how the system works precisely. In visible light communication, the LED is used for not only illumination but also optical wireless communication. In order to implement this technology, three main components are required. The LED that we see every day, the LED driver or the so-called current modulator, and an app on the phone for the user interface. Now, let's move on to see the cooperation between these three components. As we know, the LED light is stationary. However, under the camera lens, it will display a strip pattern as we can see here. That is because the LED is actually powered by alternating current and blinks at a very high frequency that we can observe with naked eyes. Those strip patterns can be used for information encryption, just like using QR code. But how can we do this? The secret is a small box called the current modulator. It's connected in the circuit for programming the current that passes through it. By applying this device, we can generate whatever kinds of AC current as we want and thus make the LED switch on and off in a certain way. If I use the LED switching on for number 1 and use switching off for number 0, then this kind of blinking mode can be viewed as a stream of binary number which is used in computer languages. When those languages are transmitted by light, we can detect them using the front camera on the phone, and an app can help us translate them and display understandable message on the screen. That is how the service is provided to us. Although the whole process seems to be complicated, the related theory is actually very simple. The orthogonal frequency division multiplexing is a method for encoding data on multiple carrier frequencies. The main advantage of the OFDM is that different messages can be transmitted simultaneously. Look at this diagram. Each of these impulses represent a unique channel. For example, if I want to send hello and how are you, then the first sentence can be transmitted using this channel, while the other one can be here at the same time. That is just like two cars go side by side on one road, which can largely increase the efficiency. Besides the OFDM, how can the system decide when to send the information to the user? It's important for a location-based service to know where the user is. As we mentioned before, if one LED encodes the data of its position inside the building, then when the user's phone camera captures this light bulb, his location can be estimated. And if the user is close enough to one of these points of interest, the system will be automatically triggered to provide service to him. Imagine the light of this lamp contains the location data, which is study room number 1 in the library, and I'm standing right under it. When I turn on the app on my phone, the system will immediately know that I'm inside the study room number 1. Meanwhile, since I'm close enough to the LG1 canteen, the system will automatically provide food recommendation to me through the app. That sounds powerful, right? Okay, let's do a review. First, the LED can be configured as a data transmitter, and when my phone camera detects the light, my location can be calculated. After this, the smart system will analyze the location data and actively send information to me. Multiple services will be provided by the app, and all I need to do is simply holding my phone. Thank you.